Hello, and welcome to the first FMSP Core Prerequisites video. These videos are designed to help you get ahead with independent study of the A2 Core, ready to develop the skills in A2 Further Pure modules. As this is the first video, there's no prior knowledge required other than what you already know from having completed AS Mathematics. Pause the recording now and go and get everything together if you don't already have these items to hand. And make sure that you've set aside enough time not just to watch the video, but to pause it regularly and have a go at the questions set before watching the solutions. This is what we'll be covering in this video. The first thing is a bit of a recap. Can you remember what these graphs look like? Pause the video and sketch them now. Okay, this is what they're supposed to be like. Let's see if yours look like this. Y equals sine x first. You need to remember that sine of 0 is 0. And then it goes through the origin. And we need to label the axes, the maximum and minimum values, and the intersections. And now y equals cos x. So the key bit of information is that cos of 0 is 1. If you forget those, you can of course check them on your calculator, but it will be good by this stage of your A-level course if you can remember those key values, even if none others. Okay, maximum and minimum minus 1 and 1 again. Intersection at pi over 2, minimum at pi, 3 pi over 2, 2 pi. And symmetric, cos of course being an even function and sine being an odd function. And then tan. With tan, it's a good idea to draw in the asymptotes first. So there's the first one at pi over 2, then intersection at pi, another asymptote at 3 pi over 2, another intersection at pi. And negative x, asymptote, intersection, asymptote, intersection. So let's draw that in. There we go. Do make sure that your graph doesn't touch the asymptotes. Okay, that's what they look like when generated by a computer. And you need to be able to sketch those quickly and confidently. Then you'll be able to deal with the new functions. So here's the first new function, y equals arc cos of x, and that's just the inverse function. So that's the same as saying that x is equal to cos of y. So if we think first of all what the cos graph looks like, and then to get the inverse function we need to reflect that in the line y equals x, and that's going to give us something like this. So that's 1 and minus 1, pi over 2, pi, 3 pi over 2, and so on. Now, this isn't a proper function because for certain inputs, for example 0, we've got several different outputs. So we need to restrict the function, and we're going to scribble out that bit at the top and so on, and scribble out everything down here, and leave ourselves just with that little bit there between -1 and 1 with unique outputs. So this is what they look like on the same axis drawn carefully. The red one is arc cos and the blue one is cos of x. So that maximum value there is pi. The crossing point there is pi over 2, and the inputs range from -1 to 1. Okay, let's try arc sine. This, of course, is the inverse of sine, so saying y equals arc sine x is exactly the same as saying x equals sine y. Pause the video now and see if you can work out this graph yourself. Okay, let's tackle it the same way as we did the last one. A quick sketch of y equals sine x, and then reflecting that carefully in the line y equals x, and we get and this time we're going to restrict it there and there. So it's going up to pi over 2 and down to minus pi over 2, and with inputs as before ranging from 1 to -1. Okay, so this one here, the red one is arc sine and the blue one is sine. And finally for this family, arctan x, which unsurprisingly is the same as saying that x is equal to tan of y. Again, pause the video and try to sketch arctan. Okay, have you remembered to restrict what you've drawn so it's a proper function? Let's do this sketch. Again, quick sketch of tan, so I know what I'm looking at. No point in putting any repeated bits in because I'm not going to want them anyway. Reflecting that in the line y equals x is going to give me horizontal asymptotes. Did you mark those on your sketch? There we go. Horizontal asymptotes at pi over 2 and minus pi over 2. But this one has the full domain of the whole set of real numbers. There we go, asymptotes drawn in but not labelled, so let's get those labelled. The red line is arctan and the blue line is tan. Okay, now we're going to look at a new family of 3 functions. These are the reciprocal trig functions. So sec x is equal to 1 over cos x. Again, we're going to start the sketch by sketching cos x, and then we're going to think about what 1 over that looks like. I'll change the colour to make it stand out. So the first thing to note is that when cos x is 0, sec x is going to be undefined, and so we're going to have some asymptotes. Then there are the easy points to note, that when cos x is 1, then sec x will also be 1, and when cos x is -1, then sec x will also be -1. And then as cos decreases from 1, sec is going to increase, and as cos increases from -1, sec is going to become more negative. And we get a shape something like this. Here's one I prepared earlier. So the red one is sec x and the blue one is cos x. You can see how they're related to each other there. Okay, so cosec is 1 over sine. Pause the video and try sketching this for yourself. Okay, did you remember to put the asymptotes in? Here's the graph of sine x. And asymptotes wherever it crosses the x-axis. And exactly as before. Okay, here's the computer-generated version. And the last one in this family, cotan, is 1 over tan. So again, pause the video and have a go at this one. This one's a little bit different from the others. Let's get our sketch of tan done reasonably carefully first, alternating asymptote and intersection, evenly spaced. And draw in tan. Try not to let your graphs touch the asymptotes. Now then, let's have a look at, let's label that first. That's y equals tan x. Now let's have a look at cotan. First of all, at all the zeros, we need to put in asymptotes. And then note that although tan x is undefined for x equals pi over 2 and so on, y equals cotan of x is defined at those places, and it's defined to be equal to 0. So it's all positive here, and it goes down to 0 at the other asymptote, and then down to infinity there. Zero at the asymptotes of tan, and has an asymptote where tan is 0. Quite a satisfying one to draw there. Hit the asymptote a little bit. Make sure that you do your sketches in pencil so that it's easy for you to erase. You need to know an abbreviation here. Cotan is often abbreviated cot. So that's the red graph. And here's the one that I prepared earlier. Okay, pause the video to work out the answer to this question. If you've worked it out, check your answer. So cot of 210, cot is 1 over tan, so that's saying tan 1 over tan of 210. Tan repeats every 180 degrees, so that's the same as tan of 30, which, if you don't already know, is worth learning, is 1 over root 3. So that's 1 over root 3, which is root 3. So the answer was B. Again, pause the video while you work out the answer. And now going through the solution. Sec of minus 390 is 1 over cos of minus 390. Cos repeats every 360 degrees, so that's the same as cos of minus 30. And cos is an even function, so that's the same as 1 over cos of 30, which is root 3 over 2. And therefore the reciprocal of that, 2 over root 3, which is B. And one more. Pause the video again while you work this one out. Okay, you could use a calculator, but it's perfectly possible to do these without. Arc cos, so let's think about what the cos function looks like. When is it minus a half? It's minus a half here, which is 2 pi over 3. And tan is minus 1 at minus pi over 4. So arc cos minus a half plus arc tan minus 1 is equal to 2 pi over 3 plus minus pi over 4, which is 8 pi over 12 minus 3 pi over 12, which is 5 pi over 12. So that was A. Okay, the second part of this topic is Pythagorean identities. You already know one of these from the AS course, sine squared x plus cos squared x equals 1. We can get two new identities simply by rearranging this one. We're just going to divide through by cos squared. So that gives us sine squared x over cos squared x plus cos squared x over sine squared x equals 1. Sorry, over cos squared x equals 1 over cos squared x. Sine squared over cos squared is tan squared. Cos squared over cos squared is 1, and 1 over cos squared is our new function sec squared. So there is a new identity using one of our new functions. We can do the same thing by dividing through by sine squared x and get another identity. Pause the video and do this one yourself first. Okay, so dividing through by sine squared x gives us 1 plus cos over sine is cotan, so that's cot squared. And 1 over sine is cosec, so that's cosec squared. And there's another identity. So we've got 3 identities here. You need to learn them, or at least you need to know how to derive them quickly and remember that they exist so that you can use them in solving other problems. Here's an example of where they can be used. I'll work through this one for you. We start by deciding which identity to use. We've got cot squared and cosec. Now our Pythagorean identities all involve the squares of functions. So we want the one that's involving cot squared. That's 1 plus cot squared x equals cosec squared x. And that's good because that's going to give us cosec, which we've already got in there. So we just substitute that in. Cot squared is cosec squared minus 1. And rearrange 2 cosec squared theta plus cosec theta minus 1 equals 0. Now this is just a quadratic in cosec. If you find it helps, you can rewrite cosec as c, and that gives us the simple quadratic 2c squared plus c minus 1 equals 0, which I'm sure you can factorise. And then you just substitute back in. Don't feel you need to do that if you can see how to factorise it without. And that gives us 2 possible options. Cosec theta equals a half, or cosec theta equals minus 1. Now sine has to be between -1 and 1, so cosec can't be between -1 and 1, so that one's not possible. So we just go with cosec being equal to -1, and that gives us that sine theta is -1, and therefore that theta is 3 pi over 2, because we're only looking for solutions in this range. That should say 2 pi up there, otherwise we're not going to get a solution. Okay, pause the video this time and work this one out before you listen to the solution. Okay, the Pythagorean identity has to deal with the squared one, which is sec squared. So we're going to use sec squared theta equals 1 plus tan squared theta. And that means that 2 lots of 1 plus tan squared theta plus tan theta equals 8. Tidying that up into standard quadratic form, 2 tan squared theta plus tan theta, that's plus 2 minus 8 is minus 6 equals 0. And factorising 2 tan theta minus 3 tan theta plus 2, giving us tan theta is 3 over 2, or tan theta is minus 2. And on our calculators, making sure we're in degrees mode for this question, we get theta is 56.3 degrees, or theta is 116.6 degrees. And that's C. Okay, what next? You need to do some consolidation of this. Don't skimp on it. You have to do it sometime, and now is the best time so that you're really confident with this material when your further pure teacher wants to build on it for your next module. I hope you found this video useful. The next one continues with trig and looks at some more identities, the addition formulae. Goodbye.